Hi, welcome to my channel Cloud with Girish. Did you know that you can use the DeepSeek R1 Distilled variation without the need for any infrastructure or server setup? Yes, this is made possible by Amazon Bedrock. Not only can you invoke the DeepSeek R1 Distilled model using Bedrock Playground, but you can integrate it with other services like Lambda and API Gateway. You can build it using AWS SAM as well. Let's bring it all together in this session. In this video, I will explain how to use Amazon Bedrock to import DeepSeek R1 Distilled model and then invoke it using a REST API and Lambda function. I will use DeepSeek R1 Distilled Llama 8B model for this solution. This is one of the 6 distilled models provided for DeepSeek R1. Let's look at the architecture diagram. In this architecture, user is invoking an API that is hosted using AWS API Gateway. API is invoking a Lambda function, and Lambda function is in turn invoking the Bedrock API, which is using the DeepSeek R1 Distilled model hosted in S3 bucket. We are using CloudWatch for the logging, and the function itself is written using Python and Boto3 SDK. You need to have familiarity with the AWS Management Console, a basic understanding of AWS CLI, a basic understanding of Amazon Bedrock Service, a basic understanding of Lambda and API Gateway, and basic understanding of AWS SAM. Let's get started. We'll look at an intro to Amazon Bedrock. We'll look at the overview of DeepSeek R1 Distilled model. I'll download the DeepSeek R1 Distilled model, and then I'll create a S3 bucket, and we'll upload the DeepSeek R1 Distilled model in that bucket. Once it's in S3 bucket, I will import the model to Amazon Bedrock service, and then we'll validate the model using Amazon Bedrock Playground. Once we have validated the model, next step is to build the Lambda function and API using AWS SAM, and then we'll invoke the model with Amazon Bedrock via API and Lambda function. I will test the API using Postman, a popular tool for API testing and validation. And then at the end, we'll clean up the resources like deleting the local model file, we'll delete the imported model, we'll delete the S3 bucket, and of course, we'll delete the tech stack created for Lambda function and API. So let's look at the intro to Amazon Bedrock. Amazon Bedrock is a fully managed service that provides access to a variety of foundation models, including Anthropic Cloud, AI21 Jurassic 2, Stability AI, Amazon Titan, and many others. As a serverless offering from Amazon, Bedrock enables seamless integration with popular foundation models. It also allows you to privately customize these models with your own data using AWS tool, eliminating the need to manage any infrastructure. Additionally, Bedrock supports the import of custom model. In this video, I will demonstrate how to use this feature by importing the DeepSeek R1 Distilled model into Amazon Bedrock. Let's look at the overview of DeepSeek R1 Distilled model. So DeepSeek R1 offers 6 distilled models ranging from 1.5 billion to 70 billion parameters. Key benefits of these models include lower computational requirement and high performance. They are well suited for local hosting and serverless use cases. For this exercise, I will use one of these 6 distilled models. So I'm going to use DeepSeek R1 Distilled Llama 8B model. So first step here is to download this DeepSeek R1 Distilled model. So I'm going to download this model from Hugging Face. If you are not familiar with Hugging Face, it's an open source community that provides repository for machine learning and LLM model. While it's distilled, it's still a large model. Hence, I will first get the LFS installed. So command to install is brew install git LFS. So that will give me the LFS, and I will initialize it by git LFS install. Once I have done it, I will clone the Distilled model repository. It's a standard command for git clone. So I'm using the command git clone, and I'm providing the URL to the Hugging Face Distilled Llama 8B model. And that will get me the model files in my local. Now I have the model. So I'm going to create an S3 bucket using AWS console, and I will log into AWS console, go to S3 service, and then I will create a S3 bucket. I'm naming that bucket as GB test DeepSeek or another name you can use of your choice. One thing to keep in consideration for S3, the name must be unique. So it's a globally unique name for S3 bucket. So here is like how I'm creating a simple process. I'm using the management console. You can use CLI and SDK and other ways, but this is the simplest way. I'm combining the way here, like I'm using the console. I'm going to use CLI for some scenario. I'm also going to use infrastructure as code. The idea is to show you all different ways that you can interact with AWS services. So once S3 bucket is created, I will upload the DeepSeek R1 Distilled model to this bucket. Now, again, there are multiple ways to upload the files into S3 bucket. You can use AWS console. You can use an SDK, write a program. You can use AWS CLI. You can also use AWS sync service, a managed service to sync the data from your on-prem to AWS cloud. I will use AWS CLI command to upload the model into S3 bucket, and the command is listed here. So I'm using AWS S3 CLI command, and I'm saying, hey, recursively take this model file, and in this region, upload it to the S3 bucket. Now there are a lot of files here, so it may take up to 30 minutes to upload the model file into S3 bucket, depending on your computer internet speed. I think it's about 15 to 18 GB files for this Distilled model. Once you see the message that, hey, model has been uploaded, then you can go to the AWS console, navigate to your S3 bucket, and confirm that model has been uploaded to the bucket. You should see a whole bunch of file in your S3 bucket. Now the files are sitting in the S3 bucket, but the model files are still not available to Amazon Bedrock service. So next step we need to do is to import the model to Amazon Bedrock. So for that, I will go to the AWS console. I'm going to navigate to Amazon Bedrock, and then I will say, hey, I want to import a model. So it's going to ask me that where the model files are. So I'm providing the bucket location here and where exactly that bucket is. And then I will hit import, and I should see a message that model is being imported. So it will show that it's importing. Again, it's a lot of files. So it may take 5 to 20 minutes for the import model job to complete. Once the job is completed, then you will see that model is in the imported model list. So this is how it should look. It's the model has been imported. So it's in that imported model list at this point. So that means it's ready for use. Now, since model is showing up, I actually can use the standard Bedrock playground feature, which is like, hey, open in playground, and then let's use few prompts, right? So that's what I'm doing here. I'm simply opening that model in playground, and then I can pass some prompt here. And then once I have like prompt is processed, then I should see a response. So here, if you see, I ask, hey, can you recommend 3 places to visit in New York? And if you see here, I'm getting the recommendation from this model that, hey, here are 3 places like Brooklyn Bridge, the Central Park, the Metropolitan Museum of Art. So it's actually providing me the response. So this response is coming from the imported model. Now we know at this point that model has been imported, it's working as designed, I can pass the prompt, I can get the response, right? But my end goal is to not use it through the playground. Rather, I want to create a service around it so that I can give that service API endpoint to the consuming app, which could be a chatbot, could be another app, but we need to integrate it via an API. So to do that, next step is that I will build a Lambda function and I will integrate the Lambda function with a REST API, and I will use AWS SAM, which is the serverless application model, a IAC framework, so infrastructure as code, so that I can build the entire tech stack, I can destroy it. There are multiple models, multiple ways that you can do infrastructure as code, right? So AWS SAM is built on top of CloudFormation. Terraform is another popular mechanism, but I'm using AWS SAM here. So again, this API will invoke the Lambda function. Lambda function has the code to invoke Bedrock, and then Bedrock will use the imported model to provide the response to the prompt. So when resources are being built using IAC approach via AWS SAM, all resources are defined in a template YAML file. And this here is how template YAML will look for this solution. So here, if you look at it, I have two key resources here. One is my API, so I'm naming the API. And then if you notice here, not only I'm naming the API, but I'm also defining the quota for that API. And basically I'm making the API secure. So like I'm saying API key required. That means any consumer who need to invoke this API, they simply can't just have a URL and invoke it, right? That's an unsecure API. They need to pass an API key, and then only they can invoke the API, right? So that's this module is doing here. And then in the second resource that I have is the function itself. And here I'm providing the function name, I'm providing the handler, I'm providing the runtime, which is Python in my example. And then I have some policy for execution. And then of course, via the event, I'm mapping it to the API that I want to create through this template.yaml file. Now that we have looked at the template.yaml file for AWS SAM, let's look at actual function code. So the function is written in Python using Boto3 SDK library for AWS. Here is our Lambda handler. It has some basic logger steps, getting the value of the environment variables, also getting the event and the HTTP method from the API event. And then I'm going to invoke a custom function here, which is like generate conversation, where I'm passing the prompt. And inside that function, actually, I'm invoking the Bedrock API. So I'm using the Bedrock runtime, and that's a standard method provided by the Bedrock API. And I'm invoking it and passing the prompt and getting the response back. And this response will be then returned back to the API. Once I have my template.yaml and my code all ready, then I'm going to use AWS SAM build command to build the code. And this framework actually allows you to build the code locally and then invoke it locally before you deploy it to the AWS cloud. So the command is very simple, SAM build. Once I run this command, if everything is properly set up, then I should see a build succeeded message. And if build is successful, that means I'm ready to use this function. And then I can use SAM local invoke command to invoke it locally. And at this point, the code is not yet deployed in AWS cloud, but it's the AWS SAM ability that I'm using to invoke this function code locally. Command to do that is SAM local invoke and give the whatever function name you have, and then you pass the a test event that has the prompt in it, right? So that's how like you can invoke it. So we'll see it in the next slide here, and then you can get the log and so on. And then once everything looks good, then we are ready to deploy it to AWS cloud. So once code has been built, next step is to invoke it. And then if invocation is providing you the result per the design and your expected output, then you are ready to deploy that into the AWS. So again, right now I'm invoking it locally. So using the SAM local, and then I can see that function actually is returning the responses that I expect. That means in my next step, I am ready to deploy the code to AWS cloud. And the command to do that is SAM deploy -g. G stands for guided. So basically it's gonna show us some prompt, and we have the opportunity to select the region and couple of other parameters as it get ready to deploy the resources in AWS cloud. Now, once you provide all the information, at the end, you will see that it's gonna ask you that, hey, here are the component of the change set, and do you wanna go ahead and deploy? And if I confirm, then it's gonna take all this list that it has accumulated, and it will deploy in my account. So at this point, I will have an API endpoint to start invoking the function. So now I can invoke the API, and I'm going to use Postman to invoke the API. You can use any tool that provide an API invocation functionality. So here I'm using Postman, and if you see, I'm passing the URL here. Of course, it's a secure API, so I do need to pass the API key. If I don't pass the API key, then I will get like 403 response, which is a forbidden message. So that's just something to keep in mind based on the template.yaml that we have. So here I'm asking, hey, it's Columbus, Ohio in Midwest, and model gonna think through this and gonna provide me a response along with the reasoning. If you see here, another prompt I am passing and say, please suggest 3 places to visit in New York City. And again, you will see that model is thinking, and then it's providing me the final response based on the prompt. I can also do a summarization use case. As you know that with GenAI LLM, summarization is a very popular use case, right? Transcript summarization, the business case summarization, the meeting note summarization, you name it, right? So here I'm passing a transcript and I'm asking it to summarize that in this particular prompt. Now, one thing to keep in mind, right, as you will see that DeepSeek R1, it's a reasoning model. So that means it will think through, it will like say how it's coming to that summary or the conclusion. That's why you see a lot more additional information here. So it's thinking through, it's providing the reasoning, and then it's providing you the output. So just something to keep in mind. Once we're done with this exercise, ensure to delete all the resources created so far so that these resources do not incur charges impacting overall cloud cost and budget. We have multiple resources to delete for this workshop, so let's look at them one by one in this list below. So we need to delete the local model file to free up the space. We will delete the model from the S3 bucket, right? Because we're looking at about 15 to 18 GB. Then we'll delete the S3 bucket, and then we'll delete the imported model. Now in the end, we'll delete the Lambda function and API. So in this workshop, I demonstrated how to use DeepSeek Distilled model with Amazon Bedrock. I imported the custom model into Bedrock and invoked it using REST API and a Lambda function integrated with the Amazon Bedrock service. I used the AWS CLI. I also used AWS Management Console. I also used AWS SAM and then Postman to validate the API before integrating it with the consuming app UI to provide end-to-end functionality. I hope you found this tutorial both helpful and informative. I'm constantly working on new content covering various AWS topics, so please take a moment to like this video and subscribe to the Cloud with Girish channel. Your support helps me continue creating valuable AWS tutorials and workshops. Stay tuned for more exciting content. Thank you.